Welcome to EDU World Space.
So once again, we have a new problem. It's a tennis ball. We're given a tennis ball. We're going to call it a mass regulation tennis ball. So we'll give it a mass regulation tennis ball, and um, it happens to have a mass of 57 grams, which we're going to change to kilograms right away by multiplying that by um, the conversion factor. 1 kilogram is 1,000 grams. So this changes to um, 0.057 kilograms. So that's a tennis ball we're given. And there are two people. Well, there is a big Bill um, Tilden. This is out of 1957, or rather, he was like he served the tennis ball in 1931. So this is Big Bill Tilden, and so he happens to like have a racket, like a tennis racket. Okay, I think I'm I'm just gonna change that a little bit. So he has this tennis racket, and it's something like this. So he serves the ball. So the initial velocity uh, of the ball is 0 meters per second. Um, and then when he makes contact, when the tennis ball makes contact, this is before. Okay, so this is before contact, and then we also have after contact. So after contact, uh, we still have the racket and the tennis ball. So after contact, we have a velocity on the ball, um, which happens to be um, 73 meters per second. So this is what we have with Big Bill Tilden. Um, and so we also know something about the contact time, that the contact time happens to be, or we call it delta t, because it's changing the time it takes to hit the ball. The ball touches the racket is 30 milliseconds, which is the same as, if you change that to seconds, you have to divide by 1,000. So this is the same as 0.03 seconds. So that's the time it takes to hit the ball. And so the ball flies, goes all the way to the other side, and meets a second player. Okay, meets a second player after the contact. Um, and the second player hits back. Okay, the second player hits back. So um, the the um, this is the opponent. So the second player is the opponent, and the opponent happens to be on this other side. Okay, so the opponent happens to be on this other side, and they also have a racket. Okay, they have their own racket, and you know, so we have before contact, and then we also have after contact. Okay, so after contact, the racket touches the ball, and the ball is going to have some type of contact. The ball is going to have some type of contact, and he hits the ball. So this is before contact. After contact, the opponent hits the ball with a speed of 55 meters per second. So this is what we're given. I would say Big Bill Tilden, the initial velocity, I'd call it BI, just for Bill, or Big Bill, and then B final, and then this is the opponent, um, opponent final, and then opponent initial. So opponent initial velocity happens to be 73 meters per second. And then final velocity is going in the opposite direction. Remember, this way is positive, this way is negative, and so this would be negative 55 meters per second. So this is the information that we're given. We're supposed to find a couple of things about this problem. We want to find the impulse. Remember, impulse is just the product of the force and the time. So we want to find the impulse of both Big Bill Tilden and the opponent, and we also want to find the force. So we want to find the impulse and the force for both of them. Okay, for both of them. So in part A, we're going to go to the next page. In part A, we're going to deal with Big Bill Tilden. I will say before contact, um, his momentum, initial momentum, equals to initial velocity times the mass, or mv. I gotta switch it. I have to switch it. So I have the mass and the initial velocity. Okay, so this is the mass. This is the initial momentum of Big Bill Tilden. So mass times initial velocity, which happens to be, remember the mass was 0.057. Okay, 0.057. So 0.057 kilograms times the initial velocity, which is 0 meters per second, and that gives me 0 kilogram meters per second. And then we also have the final momentum. That's after the contact. So this would be before contact, and this would be after contact. After contact. So the final is the mass times the final velocity. So this is 0.057 kilograms times the velocity is 73 meters per second. And that gives us a momentum after contact that happens to be 4.16 kilogram meters per second. Okay, 4.16 kilogram meters per second. So if we want to get the momentum, or what we can call the change in momentum, which is so change in momentum for Big Bill Tilden, change in momentum for Big Bill Tilden, J, is the final momentum minus the initial momentum. And this is the final momentum is 4.16 kilogram meters per second minus the initial momentum, 0 kilogram meters per second. And that gives us, if you can recall, when we go back, we wanted to find the force and the impulse. But in this case, we're going to see the connection between momentum and impulse. Remember, impulse is Ft, and that's the same as change in momentum, or final momentum minus initial momentum. So that's where we're headed. We have 4.16 kilogram minus that gives us 4.16 kilogram meters per second. And so I'm just going to do this in the next page. So if the impulse, which is force times the change in time, so this is the force and this is the change in time. If the impulse is equivalent to the change in momentum, then you could see that the force obviously has to be the change in momentum over the change in time. The change in momentum for Big Bill Tilden happens to be 4.16 kilogram meters per second over change in time, which is 0.03 seconds. 0.03 seconds. So that gives us right here 0.03 seconds. And so in this case, we need a calculator for that. This is 0.057 4.16. Okay. And then we have 4.16 divided by 0.03, and that gives us approximately equal to 138.7 kilogram meters per second squared, which is approximately 140 newtons. So you can see the force involved is 140 newtons. And then the other thing they were asking for was the impulse and the force. Remember, the impulse is impulse happens to be force times change in momentum, which is a change in time, which is change in momentum, and that gives us 4.161 kilogram meters per second. So that's for Big Bill Tilden. In the next part, we're dealing with the opponent. And you can recall from the beginning, this is the case of the opponent. We have to think about what happens before contact. So before contact, the velocity is, would say that's the initial velocity of the opponent before contact, happens to be the 75 meters per second, and then the mass, obviously, as you can recall, is going backwards, it's 0.057. So then the initial momentum of the opponent is the mass times the initial velocity, which is 75, this should be kilogram right here, 75 kilogram meters per second times 0.057 kilograms. And that's just similar to what happened with Big Bill Tilden, which is 4.16 kilogram meters per second. And then we have after contact. One thing you want to see before contact is that we had a positive, because the ball is moving that way, in the positive direction. After contact, it's moving in the negative direction. So the final velocity is negative 55 meters per second with the mass of 0.057 kilograms. So the final momentum for the opponent happens to be the mass times the final velocity, which gives us 0.057 kilograms times negative 55 meters per second, and that one ends up being negative 3.14 kilogram meters per second. So, you just want to make sure that your numbers are right. And so going to the next page, we want to find the momentum. So the initial, if you can see from here, the initial momentum uh, for the opponent is positive 4.16, and then the final momentum is negative 3.14 kilogram meters per second. And so the momentum of the opponent, okay, the momentum, we need to change this. The momentum of the opponent, which I'm going to call P opponent. As you can recall, we also had the momentum for um, for Big Bill Tilden. Okay, the momentum for Big Bill Tilden was this one, and then we want to get the change in um, the impulse. Okay, so to get the impulse, remember the impulse is Ft. Okay, the impulse is Ft. So I just want to make sure this is right. So the change impulse equals to force times delta t, which is the same as change in momentum, but then the change in momentum equals to the final momentum minus the initial momentum. The final is negative 3.14 kilogram meters per second. The initial is 4.16 kilogram meters per second. If you put those two together, you get negative 7.30 kilogram meters per second. And so the impulse for the opponent happens to be negative. So the opponent's impulse is negative negative 7.30 kilogram meters per second. Impulse F delta T equals to delta J. So if you want to find the force that the opponent is using, is delta T over delta J. So we have negative 7.30 kilogram meters per second all over time. It's still the same 0.03 seconds. And so if you put those two together, you get it's a negative number, negative 240 kilogram meters per second squared, which is the same as negative 240 newtons. So in that case, this is the net force for the opponent pointing towards the left, and this is the impulse also, the change. It's negative because remember initially the ball is coming with a positive momentum and then it has to switch to a negative. And then if you move backwards, these are the computations. That's the opponent. Bill Tilden also has the same situation where he has an initial momentum, final momentum minus initial momentum, which is zero. The initial momentum is zero because at the beginning we don't have a velocity. And so this is the change in momentum. We end up getting the impulse for Bill Tilden and also the net force. I hope you enjoyed the video. Thanks very much for watching. Hoping to see you next time, and have a wonderful day.